you are watching the 9 o'clock news and you are watching the weather. Okay? In that also you may be seeing this 4 numbers. Now what can you say? Now you can say temperatures recorded at 4 metropolitan cities. Right? Now, when you are seeing the same numbers in a specific context, and when you see that it is some centigrades or Fahrenheit or whatever it is, now you know something more than what it is, right? You know that it's not just numbers, it is temperatures, it has some attributes, right? The attribute here is centigrade, right? Now, initially the 4 numbers which you see without the context is 4 integers. Now, when you see this in a particular context, it becomes information. Okay? Now, assume that I am asking you to tell which is the hottest city today. How do you find? You arrange the numbers in an order and find the maximum, right? Or in other words, on these numbers you apply a procedure to sort the numbers, right? So initially what you saw is numbers, which is data, which is called what we call as raw information. Okay, when you looked at it with the context, with some attribute added to it, it becomes information. And if you are able to find which is the hottest metropolitan city today, it becomes knowledge. Now, assume you are a salesman and you are asked to choose one of these cities to travel today. Which one you will choose? Obviously the coolest one. Nobody will be interested in going to the hottest place, right? So, now you choose or you act on the data, and the action out of this knowledge is what we call as intelligence. Okay? So we have data which is raw. Then when you add some attribute, it becomes information. If I can add some procedure to that, okay, so that I will be able to process it better and find the maximum or whatever basic number crunching operations you can do, then it becomes knowledge, and the action out of this knowledge is what we call as intelligence. Okay, so we have something called IT application triangle. Okay, there is a famous IT application triangle. Okay, whether you are in computer science or IT, it doesn't matter. In this application triangle has 4 things. At the bottom we have data processing. On top of it we have information processing. On top of it we have knowledge processing. Above all we have intelligence processing. Okay, so but everything is dealing with data. Understand one thing, the machine can understand only zeros and ones. That's why any digital computer is called GIGO. Garbage in, garbage out. It's a stupid machine which can understand only ones and zeros, but we get maximum out of it because we are able to design and develop systems which can get meaningful information out of it. Okay, so you name any application in this world with which a computer can do, it can fit into 4 categories. Any one of these 4 categories. Either it can be data processing, or it can be information processing, or it can be knowledge processing, or on the top we have intelligence processing. Today we are in the intelligence era, where if you walk into this room, there are now sensors which can detect who you are. Now in airports they don't do intrusive checking. They check your iris and find whether it matches with your passport. That is computer vision. That is an intelligent processing application. Or you can have a doctor replaced with an expert system which can prescribe medicine for you. That is typically what we call as a knowledge processing. today you book tickets using your IRCTC. Am I right? You don't go and wait in the railway station. That is typically an information processing system. And mere number crunching which you do in your labs is what we call as a simple data processing application. So, whatever may be the application, today you know that you have to manipulate data. That means you should have efficient mechanisms by which you can design and develop systems which can operate on the data. Okay, so it's okay. And try to understand how effectively and efficiently you can design a database. Okay, remember that even today, even though we are in the intelligence era, today if you have your brothers or sisters working in industry, okay, IT industry, they will be most of the times working with data only. Okay, and most of the IT engineers work most of the times on database management. So this is one of the very important subjects, and you must have good knowledge of how to design a database, and that will really help you after completing this 4 years program. Okay, so we will try to understand. So this is what I was just talking about. Data is an essential part of our everyday life. Today, from the time we get up till the time we go to bed, we use data. Of course, today we may not have a residential address, but we have an email address, right? Today, every one of you have a Facebook account. Whether you have a passbook or not, but you will have a Facebook. Okay, so everybody tweets, right? Today, when you are watching a match, next minute when a ball is bowled, you tweet and say, "Hi, this guy has hit a 6 or 4," which means every minute millions of data is getting generated. In fact, today the recent trend is we talk something about big data, where voluminous data is being generated from this Facebook, Twitter, which we call as unstructured data, and they are finding it extremely difficult to manipulate and manage this data. Okay, so we will try to understand where this data finds its applications. One of the common applications which everyone knows is banking. In banking, everything is data, right? How much money you have today, how much you withdraw, then how much you put. Okay, even if you don't, your parents do it. Okay, then airlines, reservations, airlines or train or whatever it is, we deal with data. Then universities, Anna University, now every 1 month now they are asking for your performance data, right? It's no longer like at the end of the semester. So every time we handle this data, we have to remember that it's not so easy as we think, even though we like to have it as simple as possible. Then finance, of course, which is related to banking. Okay, now okay, this slide we will come back to later. Go to the next. No, next. Yeah. I will tell you something. I mean, you may not understand everything, but still I will try to tell you something about this. Whenever we want to use this data effectively, we need to model. Okay, first of all, I should know what is a model, right? Without knowing what is a model, we may not be able to appreciate what are all these types of models and all that. For example, you go to a doctor, right? How does a doctor treat you? He asks for some symptoms, right? And every disease is associated with one organ or other, correct? And sometimes some of the diseases may be related with multiple organs. So when he studies, what he studies is, he studies our human body as different systems, like neurological system, okay, respiratory system, okay, excretory system, So many systems are there, which means our human body is being modeled using different systems. Same way, we need to understand, if we need to understand how effectively we can store and retrieve the data, we need to model the data. That means we should understand how we can represent the data and how we can store the data. There are so many complexities involved in database. The most complex